Hi guys, today we will discuss the objective question that has been asked in ESE 2017 in EE domain from the subject network theory. See, the purpose of making this video is to show you that whatever I teaches you from lecture number 1 to 25, that is sufficient for cracking ESE or GATE exam, because all the questions that has been asked in ESE in 2017, that is related to the concept which I have given you in this 25 lecture. I am giving you the reference in which the concept has been discussed, whatever asked in ESE 2017 from network theory. So let us solve the first problem. In the first problem, it is saying the voltage and current waveform for an element are shown in the figure. This is the current waveform and this is the voltage waveform. And you have to find the circuit element and its value. Means whether the circuit is inductor or capacitor. Only two option is given, capacitor and inductor. So let us take both the cases. First I will take the capacitor case. This is capacitor and I am connecting one voltage source of value V across it. Okay, then what will happen when you give the supply to this voltage source, then the voltage across this capacitor will be V is equal to 2 volt. Okay, and once the capacitor is charged, then the current would become 0 because the capacitor voltage will oppose the input voltage. Here input voltage is equal to 2 volt is given. So if you will give supply V is equal to 2 volt across the capacitor, then the voltage drop across the capacitor will be 2 volt and the current will be 0. But in this graph you are seeing that when you give supply to the element, then the current increases linearly and becomes constant after 2 seconds. So according to graph, the element is not capacitor. So option A and option C are wrong. Now talk about the inductor. When you will give supply, let us say V is equal to 2 volt to any inductor, then we know that inductor won't change, the current across the inductor won't change instantaneously. So voltage across inductor VL, you will get 2 volt because it is connected in parallel. So VL is equal to 2 volt and we know that this is equal to L di by dt. So inductor won't allow sudden change in current. The current will increase linearly and becomes constant after some time. So what is the change in current? See here, the change in current is 2 ampere. So we can write L di is 2 and dt is 2 second. 2 upon 2, that is equal to voltage across inductor, that is equal to 2 volt. So L is equal to 2 Henry. So the element is inductor and whose value is 2 Henry. So option B is correct. This concept has been discussed in lecture number 12. If you guys have seen this lecture, then you can easily solve this kind of problem. Now see this question. What is the current through the 8 ohm resistor connected across terminal M and N in the circuit? Means we have to find this, the value of current across this 8 ohm resistor which are connected between M and N. Let us take current I is flowing here. Okay, and at this node the voltage is Vm. So you can easily solve this circuit by nodal analysis, which has been discussed in lecture number 4. Okay, so if you know how to write the nodal equation, you can easily find the value of this current. Okay, so first find the voltage across this M terminal. Let us take this reference node and apply nodal. What you will get, Vm minus, this is plus because the negative is connected across this. So Vm minus of 8, that is Vm plus 8 by 12 plus Vm by 8 plus Vm plus 2 by 8 is equal to 0. So separate Vm here, you will get 1 by 12 plus 2 by 8, that is equal to 1 by 4 is equal to minus 2 by 3 and minus 1 by 4. So Vm you will get minus 11 by 4. So the nodal voltage across M is equal to minus 11 by 4. Hence current I will be Vm upon 8, that is equal to minus 11 by 32, that is equal to minus 0.34 ampere. See, the direction of current I have taken. Why the current is negative? Because the direction of current I have taken, that is opposite to the actual direction of current. So current will flow from N to M having value 0.34. Here the value of I is negative. So the value of this, let us take this I1 is equal to minus of I, that is equal to 0.34 ampere, and the current will flow from N to M. So option D is correct. See this. What is the value of resistance R which will allow maximum power dissipation in the circuit? Means you have to find the RTH, and this has been discussed in lecture number 7, how to find the RTH. See, this is case 1 problem. Those guys have seen my lecture number 7, they understand what is case 1, what is case 2, and what is case 3. So this is case 1 problem. What we have to do for finding the value of RTH, we have to short circuit this voltage source and open circuit the current source. Here no any current source is present, so I will short circuit this voltage source and I will remove this R. I will find the value of RTH across this. So the value of RTH will be 20 parallel with 10, 20 parallel with 10, then in series with 5, means 200 by 30 plus 5, that is equal to 11.66 ohm. See the next problem. For the circuit shown, Thevenin open circuit voltage and Thevenin equivalent resistance at terminal AB. We have to find the VTH and RTH across this terminal. So in order to find the RTH, what you have to do, you have to short circuit the voltage source and open circuit the current source. Here only one voltage source is present, so short circuit this and find the RTH across this terminal. Take 5 parallel with 5, that you will get 2.5, in series with 2.5, 5 again 5 parallel with 5, that is equal to 2.5. So RTH you will get, that is equal to 2.5 ohm. Means option B and option C are wrong. Now find VTH. So this is case 1 problem. What I will do, I will go with the nodal also, I will go with the mesh also, but here I will go with the circuit reduction method. What is circuit reduction method? I have explained you in lecture number 4 and 5. What I will do, I will find the voltage across this 5 ohm resistor, that is the 50 multiplied by 5 divided by 10, that is equal to 25 volt. I will reduce this much of circuit to this 50 multiplied by 5 divided by 10, 5 plus 5, that is 10. So overall 25 volt I will get, and I will take parallel combination of this 5 and 5, that is equal to 2.5 ohm. So I will reduce this much of circuit to like this, then in series with 2.5, okay, then in series with 5 ohm, and this is my AB terminal where we have to find the VTH. So take this series combination, equivalent will be 5 ohm, and this 5 ohm are connected in series with 5 ohm. So VTH according to voltage division rule, you will get 25 multiplied by the resistance across which you have to find the voltage, that is 5, divided by total resistance, that is equal to 10. So you will get 12.5 volt. This has been discussed in lecture number 7. Now see this question. Two resistors of 5 ohm and 10 ohm and an inductor L are connected in series across 50 cos omega t voltage source. What is saying? Two resistor of 5 ohm and 10 ohm are connected in series with inductor of value L, and this is also connected with voltage source that is given as 50 cos omega t. If the power consumed by the 5 ohm resistor is 10 watt, what is given? This 5 ohm resistor is consuming power 10 watt. What is the power? Power is equal to IRMS square into R, that is equal to 10. Here R is equal to 5. So IRMS is equal to 10 by 5, that is equal to under root 2. Now I get the current, IRMS current, that is equal to root 2 ampere. Okay, and let us take the combination of this, the voltage drop across this whole resistance, that is equal to VR, and voltage drop across this will be VL. Okay, then the VR is equal to what? VR is equal to IRMS into total resistance, that is equal to 15. So this will be 15 root 2. Okay, now draw the phasor diagram. This is a RL network, so I will take a current as a reference. So let us take this I, this is I, that is equal to under root 2 ampere. Now tell me where VR will lie. VR will be in same phase with current, so VR will be in same phase. Where the VL will lie? VL will lead the current by angle 90 degree. This has been discussed in lecture number 21, that is the phasor diagram. If you've gone through this lecture, then you can easily understand what I am doing. So this is VL, okay, and the net voltage is the combination of VR and VL, that is here. This is V, this is I, and this is the angle, power factor angle, that is phi. Now find the cos phi. Cos phi is the power factor. Power factor is equal to cos phi. A cos phi is given as VR upon V according to this triangle, VR upon V. VR I have got, that is equal to 15 root 2 by V is equal to 50 by root 2. Remember, this is the maximum voltage, okay. So you have to take the RMS voltage, because VR you are taking the RMS, so you have to take input voltage also in RMS. So finally you will get 30 by 50, that is equal to 0.6. So option C is correct. Now see this question. Two elements series circuit is connected across an AC source given by E is equal to 200 root 2 sin 314 t plus 20, and the current is found to be 10 root 2 cos 314 t minus 25. So what is given? Vt is equal to minus 25. The parameter of the circuit. We have to find whether the circuit consists of resistance, capacitance, or inductance capacitance. Okay, here only two option is given, which is a combination of RC and LC circuit. See here, Vt is given in sine form and It is given in cosine form. So you have to convert either one of them in sine or cosine. So I will convert It in sine form. I can write 10 root 2 sine 90 plus 314 t minus 25. We know that sine 90 plus theta is equal to cos theta. So if I will put theta is equal to 314 t minus 25, then I will get same like this one. So this It and this It are same. So finally I will convert It is equal to 10 root 2 in sine form, that is equal to 314 t plus 65 degree. Okay, now draw the phasor diagram. Take this as a reference. Then where the Vt will lie? Vt will lead by 20 degree. So this will be Vt, okay, and this is 20 degree. Where the It will lie? It will lead by 65 degree. So this is It, and this angle is 65. I have taken reference 0 degree here. So Vt will lead by 20 degree and It will lead by 65 degree. So overall It is leading the Vt by 45 degree. Got it? Means this is a RC circuit. In RC circuit, the current leads the voltage by some angle which lie in between 0 to 90 degree. Okay. Now we know that tan inverse Xc upon R, that is equal to phi, which is given as power factor angle 45 degree. So Xc upon R is equal to tan 45, that is given by 1. Xc is 1 upon omega c. So finally I can write 1 upon omega cr is equal to 1. Okay. So Rc is equal to 1 upon omega, and here omega is equal to 314, that is equal to 314. So multiply this option B, R and C, you will get 1 upon 314. So option B is correct. In this way you can solve this circuit. This has been discussed in lecture number 20 as well as lecture number 21 while drawing phasor diagram. See this problem. This is one of the simplest question is asked in ESE 2017. It is asking that the potential drop across the 80 ohm resistor in the figure. You have to find the voltage drop across this 80 ohm B1. Apply voltage division rule that has been discussed in lecture number 3. V1 is equal to total voltage multiplied by the resistance across which you are finding the voltage, that is 80, divided by total resistance, that is equal to 100. So you will get 20 volt. See this question. For a two-port reciprocal network, the three transmission parameter A is equal to 4, B is equal to 7 and C is equal to 5 is given. What is the value of D? Since this is reciprocal network and in ABCD parameter, what is the condition for reciprocal? The condition of reciprocal is AD minus BC is equal to 1. This has been discussed in lecture number 18. Okay. So Find D. D is equal to BC upon A. You will get approximately 9. So option B is correct. Consider the following as representation of reciprocity in terms of Z parameter. So in Z parameter, this is also discussed in lecture number 18. Reciprocity you will get when Z12 is equal to Z21. This is the condition for reciprocity. So option 3. This is the important question. It is saying if a high quality parallel resonance circuit is loaded with resistance, then what will happen? The circuit impedance reduces, the resonance frequency remains same, the bandwidth reduces. First talk about the resonance frequency. What is the resonance frequency in parallel or series network? That is equal to 1 by LC, or in hertz 1 upon 2 pi under root LC. Here no resistance is coming into the picture, so if you will add the resistance or subtract the resistance, the resonance frequency will remain same. So option 2 is correct. Now talk about the bandwidth. Since it is parallel resonance circuit, so bandwidth, this I have explained you in lecture number 24 with full derivation, that is bandwidth is equal to 1 upon RC. So if you will increase the value of R, then bandwidth will decrease. Okay, so if you will increase the value of R, the bandwidth will decrease, that means the bandwidth will reduce. So option 3 is correct. Okay, now talk about the circuit impedance. If you will add resistance in parallel circuit, then overall admittance will increase. Admittance increase means impedance will reduce. So option 1 is also is correct. So overall option D, 1, 2 and 3 all are correct. So this has been discussed in parallel resonance circuit in lecture number 24. Now see this question. What are the Thevenin equivalent voltage VTH and RTH between terminal A, B? In order to find the RTH, how will I find? I will short circuit the voltage source and open circuit the current source and find the RTH. So if you will short circuit this voltage source, then 68 and 100 will be in series. This will be 168. Then again this 120 and this is AB. Okay, so 168 parallel with 120, that is given by 168 multiplied by 120 by 168 plus 120. You will get 72 ohm. Means there is some misprint, I think. So I think option C or option D. These two are possible, these two are not possible. 72 ohm is nearer to the 70 ohm. Now find VTH. VTH across AB, just apply the voltage division rule. You will get VTH is equal to total volt, that is equal to 100, multiplied by the resistance across which you are finding voltage, that is 120, upon total resistance, that is equal to 168 plus 120. Finally you will get 41.667 volt. So option D is correct. This has been discussed in Thevenin theorem. This is case 1 problem where you are getting only independent sources. See this question. This is most important question. Which of the following are satisfied in the non-linear network? Associative, superposition, homogeneity, bilateral. I have explained you in lecture number 6, that is the superposition and homogeneity principle. I have explained you there. In the statement I have written that in a linear network, superposition and homogeneity are applicable only in linear network. So these two are applicable only in linear network. But the question is saying which of the following are satisfied in a non-linear network. So these two would be wrong. So see the option 2, 3 are wrong. Means only one option is satisfying, that is equal to 1 and 4. So no need to check about the bilaterality and associative, because 2, 3 is already wrong, and in option A you are getting 3, in option C you are getting 3, in option D you are getting 2. So these A, C, D are wrong. But I will talk about the bilateral network. I have discussed this bilateral network in lecture number 1, that is the classification of element, and I wrote down one statement that every linear element is bilateral, right? But converse is not true. What do you mean by this? Means every linear element is bilateral, but every bilateral element is not linear. It may be linear or non-linear. So I have solved one example in lecture number 1 like this. The VI characteristics is given like this. This is 4, this is 4, this is -4, and this is -4. So if you will talk about the linearity, then this is non-linear. Now talk about bilateral, whether it is unilateral or bilateral. This is bilateral. Why? Because it offers same impedance when the polarity of voltage or current get reversed. So same impedance it is offering. That means it is bilateral and also non-linear. So bilaterality is possible in non-linear network. Okay. So option B is correct. Now see this. What is the current through the 5 ohm resistor in the circuit? This you can do easily by source transformation, and the concept is discussed in lecture number 3, and I have solved some problem based on the source transformation in lecture number 5. So go through that lecture, you will understand how I am doing. So convert this current source into voltage source. You will get 5 multiplied by 4, that is equal to 20 volt in series with. So overall the current I is equal to 60 minus 20, that is equal to 40, divided by 6 plus 5 plus 4, that is equal to 15. This will be equal to 2.66 ampere. See here, direction of current is not given across 5 ohms, so you can take a current as a positive. So answer would be 2.66. Now see this problem. In the two-port network shown, which of the following is correct? Here 4 option is given. IB is equal to IC, IA is equal to ID, IC is equal to ID, and IA is equal to IB. See, in this port, IA is entering, means whatever the current is entering to the port, that must be equal to the current leaving the port. Why? According to KCL, the current entering the port must be equal to current leaving the port. So IA must be equal to IB. See the port 2. Here also IC current is entering, that means ID must be equal to IC. IC must be equal to ID. So these two condition are possible in two port network. So option C is also correct and option D is also correct. Both options are correct. See this question. The parameter for the network shown in figure can be represented by. We have to find the Y parameter. So this has been discussed in two port network in lecture number 18. I have derived one formula there like this. This is YC, this is YA, and this is YB. Okay, this is a pi network, and I have found the Y parameter, that is given by YA plus YC, YB plus YC. This is YC, this is YC. Sorry, this is minus YC, this is minus YC. See here only 5 ohm resistance is given. Then what is the value of YC here? YC will be 1 by 5. Here no resistance is given, means impedance is infinite. Impedance is infinite means admittance is 0. Okay, so YA will be 0. Here also no impedance is given, means impedance, it is open circuited, means impedance is infinite, so YB is equal to 0. Now put in this formula, you will get YA plus YC, that is equal to 1 by 5, minus YC, that is minus 1 by 5. This is minus 1 by 5, this is 1 by 5. Option B is correct. Okay, see this question. A current of 10 plus 5 sin omega t plus 3 sin 2 omega t is measured using MI instrument. This is the questions from measurement, right? But this is the application of network. As we know, MI instrument measured RMS value. So finally I have to find the RMS value of this. So IT is given as 10 plus 5 sin omega t plus 3 sin 2 omega t. And how to find? These are the harmonic component. This is the this is the DC component, this is the fundamental component, this is the second harmonic component. So if you have gone through the lecture number 22, in which I find the RMS value of current containing harmonics, that is given by IT is equal to under root of I1 RMS square plus I2 RMS square plus I3 RMS square. So first find the I1 RMS. I1 RMS here 10 is the DC, so average value is equal to RMS value. So 10 k square plus this is maximum value. So RMS will be 5 by root 2 k square plus here this is also a maximum value. So 3 by root 2 k square. So finally you will get 10.82 ampere. So option C is correct. This has been discussed how to find the RMS value which contains harmonic in lecture number 22. Now see this question. This is question from power system, but I will consider this in network only because this is based on two port network. The transmission line is represented as ABCD parameter and is given, and we have to find the condition for symmetry. So in lecture number 18 I have discussed in ABCD parameter the network will be symmetrical when A is equal to D. So option B is correct. So these are the questions that has been asked in ESE 2017 from network subjects. So whatever the question is being asked, the concept for solving that question is already discussed in lecture number 1 to 25. So if I will go with the priority, then main topic that has been asked in ESE 2017, the 5 questions came in ESE 2017 are from the basic concept that is already discussed in first 5 lecture, that is lecture number 1 to 5. Okay, then 4 question has been asked from Thevenin MPT theorem that has been discussed in lecture number 7 and 8. From two port network 5 questions has been asked, and that has been discussed in lecture number 18 and 19. So most of the questions are from lecture number 18, that is the basic. 4 questions has been asked from the AC analysis that has been discussed in lecture number 20. 21 is the phasor diagram and 22 is the power calculation. And not a single question has been asked from the transient, which is the most important subject in network, and every year in GATE exam you will get 4 to 6 marks of questions from transient. So whatever the topic ESE left, that has been asked in GATE exam. So you have to study all the topic in order to crack GATE as well as ESE. So finally I want to conclude that if you have gone through all the 25 lecture that is given by me, you would have solved all the questions that comes in ESE 2017. So 5 plus 4 plus 5 plus 4, that is equal to total 7, I think 18 question, that is equal to 18 marks. You can easily get 18 marks if you have gone through my lecture. So those guys who have believed in my teaching, they would have enjoyed in ESE 2017 while solving network, and those guys who have not gone through my lecture, they will now study after seeing this lecture number 26. So if you guys understood the concept, then subscribe to this channel and also share with your juniors, and for doubt solving you can join our Facebook group. Thanks for watching this video.